Welcome to the UNV Certification Program. The topic of this course is Video Audio Fundamentals and Encoding. By learning the course, we can know about some video concepts, as well as various video encoding standards. Meanwhile, we'll also understand the basic knowledge of audio and its encoding. This course covers 3 parts. Let's start with the first part, Video Audio Application. Here we can find a CCTV system, including front end, transmission, and back end. At the front end, the built-in microphone or pickup collects sound to generate audio, while the camera collects light to generate video. In transmission, there might be some cables, switches, routers, etc. Both a video and audio stream can be transmitted through network. Finally, at the back end, we can display the video on TV wall or store the data in storage devices. In the next part, we mainly introduce video fundamentals and encoding. First, we need to know what is a video. Actually, video is a bunch of images stacked together in sequence. So, it's made up of a series of images but creates a sense of real motion. When it comes to image definition, here we have 2 different ways to represent. Resolving power is to tell the definition of analog image. The unit of resolving power is television line, short for TVL. There are 2 dimensions of TV line, width and height. Resolution is to tell the definition of digital image. The unit of resolution is pixel. There are also 2 dimensions of pixel, width and height. We are gonna stick with resolution, since it's probably the one that we're most familiar with. Resolution is the number of distinct pixels in its dimension. Higher resolution, clearer image, and larger image size. On the left side, there are many different resolutions, varying in pixel and aspect ratio. On the right side, some typical resolutions are being shown. 720p can be called HD or high definition. This resolution has a horizontal count of 1280 pixels and a vertical count of 720 pixels, for a grand total of almost 1 megapixels at a 16:9 aspect ratio. 1080p can be called full HD or full high definition, for an even better total of 2 megapixels, and it's still a 16:9 aspect ratio. If we want something more robust than that, there is an even bigger resolution coming along. That is 4K or Ultra HD with an improved pixel number of 8 million. Some cameras support resolutions between them such as 3 mega or 4 mega, those are great quality as well. Higher resolution results in more details, but it comes with a cost. Normally, devices with high resolution are more expensive, and high resolution videos and images require more data. So, it's always important to consider the suitable resolution we need. The following video concept is frame rate. As mentioned before, video is basically a bunch of images stacked together. For a human visual system, when a series of images are played in a short time, they will be seen as motion. Each image in the video is called a frame. Frame rate is the quantity of frames per second, measured by FPS. For example, in 1 second, 25 FPS video contains 25 frames, while 5 FPS video only contains 5. It defines the speed at which those images are recorded and played, and also determines the video quality. More frames per second means a smoother video. But they also have an impact on the size of video files. If the system has a large storage capacity and bandwidth, and we need to record extremely clear video with fast motion, increasing frame rate may be an option. If not, it's important to understand the purpose of each camera and the minimum acceptable frame rate. Then, let's think about a question. In daily practice, if we want to store a video with 1080p resolution for 3 months, how much space will it take? We might as well do a calculation. The image resolution times the color depth times the frame rate equals how much raw data that needs to be recorded per second. Then times the storage time, we get a theoretical huge amount of data. That's important because all that data is not convenient to transmit and can cause problems for the camera, SD card, hard drive, and so on. Fortunately, all those engineers have come up with a lot of clever ways to encode and compress the data. Codec, or coder-decoder, is the actual algorithm used to compress the raw video, then to decompress the file for streaming or file transfer. Encoding compresses raw video into a smaller format. And decoding is essentially the reverse of encoding. Normally, the video in CCTV system will be compressed before transmission. The video after compression is called video stream. The basic parameter to describe stream is bit rate. It implies the rate at which bits are transferred from one location to another. In other words, it measures how much data is transmitted in a given amount of time. The higher the bit rate, the higher the quality of video. On the alternative side, the larger the file size of video. There are two types of bitrate. CBR, also known as constant bitrate, will consistently maintain the bit rate assigned to a camera stream, no matter what's going on in a camera's view. The pro is to control the bandwidth usage in our network. The con is it may provide a low image fidelity and excessive storage. VBR is short for variable bit rate. It will increase the bit rate when the motion occurs or the scene becomes busier, and decrease bit rate when there is less going on. To allow digital video to be processed and transmitted as efficient as possible, we need to use compression technology. Here are three kinds of encoding standards. MJPEG or Motion JPEG compresses each video frame separately as a JPEG image. Let's think about the following question. In each image, what kind of information is compressed specifically? Well, we can see the area inside the rectangle is all sky and there is no key information. Many adjacent points tend to be similar or the same, like point 1 and point 2. This is called spatial redundancy, which can be compressed by MJPEG. As a purely intra-frame compression scheme, it's simple to implement, but still inefficient compared to more modern standards. H.264 is also known as Advanced Video Coding or AVC for short. It is by far the most commonly used standard, as it provides a significantly better bitrate over its predecessor. For this reason, it's very widely supported, and we will rarely run into support issues. H.264 adopts interframe compression. The following three pictures are consecutive frames. We can find that only the person is moving, and the house in the background doesn't change. This part is called temporal redundancy. Different redundancy needs to be compressed by specific encoding techniques. H.264 uses interframe compression to remove temporal redundancy. At the same time, three types of frames are defined. iframe contains full image data. When transmitting it, the stream will be large. P-frame and B-frame hold only the changing part between frames, so they need less space in the output file. GOP stands for Group of Pictures. It starts with an iframe, includes B-frame, P-frame, and ends up with the second iframe. P-frame is unidirectional, predicted only from the previous frame. And B-frame is bidirectional, which compresses, according to the changes between the previous frame and the next frame. H.265 is referred to as HEVC, which stands for High Efficiency Video Coding. Let's make a comparison. H.264 processes information by using macro blocks, which is fixed, and the data is independent to each other. While H.265 uses coding tree units, which determines the size of code unit based on regional information, offering sharper details and better image quality. It is extremely beneficial for high resolutions and live streaming. In security industry, different manufacturers have different ways to optimize compression algorithms. Ucode is an encoding technology self-developed by Uniview. When applying with H.264 or H.265, the bit rate can be further reduced without degradation of image quality. Based on enhanced frame and intelligent region perception, it reduces at least 50% of bandwidth and allows HD video at 1 megabit per second. Today's compression technology works so smart, thus we can reduce bandwidth and storage significantly. In the last part, let's talk about audio fundamentals and encoding. Sound is collected by the audio input devices and appears as a wave. For audio signal collection, we have two types of devices: microphone and pickup. Microphone is passive device connected to the mic in of the camera, and pickup is active device connected to line in of the camera. For sound waves, there are two important parameters. Sound frequency is the number of times the voice vibrates within 1 second. And sound amplitude refers to the loudness, that is, the volume. The larger the amplitude, the greater the volume. This is the audio signal workflow. The microphone or pickup will collect the sound and generate analog audio signals from the camera. Then, the input audio signals will be processed and converted to digital signals. Finally, the camera outputs audio stream for transmission and storage. The process from analog signal to digital signal is called PCM, or pulse code modulation. First, it samples the signal and takes a value. The next thing is to quantize, which gives a whole number, the nearest available number to whatever the value is. This will lose a little bit information, especially when the signal is rapidly changing. Then, it encodes the raw data to be in smaller size. That is how data is converted from analog to digital. In encoding techniques, we have many choices, such as AAC and G.711. G.711 is recommended as a great balance between clarity and space saving. There are two main compression algorithms under it. One is U-Law, which is mainly used in North America and Japan. The other is the A-Law algorithm, which is mainly used in Europe and the rest of the world. After this course, we should have a good command of video concepts and encoding standards, while also understand the basic knowledge of audio. That's all for video audio fundamentals and encoding. Thanks for watching. See you next time.